Okay, this video is going to be for section 8.5, so you'll need your Do Now answer sheet and your note packet. So for Do Now number 5, we want to find the image of 3,5 after a rotation of 180 degrees about the origin. Again, you can plot that point on a piece of graph paper and then turn it 2 times, because again, 90 plus 90 would be 180, and then just count to see what that new ordered pair became, or you can remember the rule. Again, the rule for rotation of 180 degrees about the origin, the point xy, all we're doing is going to negate both those coordinates, so it will become negative x, negative y. So in this case, the image of A, the opposite of a positive 3 is a negative 3, and the opposite of a positive 5 is a negative 5. So A prime will become negative 3, negative 5 after that rotation of 180 degrees about the origin. So that's it for the Do Now. So again, now we're going to go into our note packets. So 8.5, dilations. A dilation is a transformation that causes a similar figure that is either a reduction or an enlargement of the original figure. Again, in class, this is the one where I usually say that you're taking a picture to CVS to get it blown up. So again, the 2 pictures that I have here that I'm putting the little asterisks by, you have a star, and again, that star is getting enlarged, and then on the triangles, you have a triangle that's going from a smaller triangle to a larger triangle. That's a dilation. Again, you can go in the opposite direction and go from something bigger to something smaller as well. The center of dilation is a fixed point from under which all other points are either enlarged or reduced. So if I look at my tiger picture here, this purple dot is my center of dilation, and you can just think of it like shooting a laser through that point to get from your original picture to your dilation. So if I just take my laser and shoot it, it first comes here and then it would come up there. Again, started at center of dilation, shoot my laser on the bottom, it would come here and then up to there. Okay, so that's all your center of dilation is. The scale factor indicates how much the figure will be enlarged or reduced. And this is super important. It must always go in this order. To find your scale factor, you're doing the image over the pre-image. And obviously, once we get to an example, you'll see what I mean by that. The variable for a scale factor is k. Okay, normally, a lot of times in class, we use x as our variable. But for this, if I have an ordered pair x comma y and I start talking about the x variable, I don't know whether I'm talking about my x coordinate or the x variable. So to stop that confusion, we use our variable here as k. It's no different than if you were using x. So all you're doing for a dilation is taking whatever that scale factor is and you're multiplying both coordinates by that. So if you start with xy and then you multiply both of them by k, that's how you get k times x and k times y. If your k value is greater than 1, your dilation is going to be an enlargement. And when your k factor is less than 1, the dilation is going to be a reduction. Your picture will get smaller. And then underneath, it's asking, is a dilation a rigid motion and why? So again, everything that we've been talking about inside this chapter, we keep bringing up rigid motion. And a rigid motion preserves both distance and angle measure. And a dilation is not a rigid motion because distance is not preserved here. The size of your figure has changed. Your angle measures are going to be the same, but your size of your sides are not. Okay, so a few short examples to get started here. What are the coordinates of the image of the point 2, negative 4 under a dilation of 2? So literally all you're doing is taking each of your x and your y and multiplying it by 2, and that is it. So 2 times 2 is 4, and then negative 4 times 2 is negative 8. So your answer there will be 4, negative 8. For 2, we want to know what the coordinates of the image of the point 9, 15 are under a dilation of 1/3. So this time, instead of multiplying, because we have a fraction, we're going to divide. So we're just going to divide each of those numbers by 3. Again, that's the same thing as multiplying by 1/3 if you prefer to keep it in fraction form. So 9 divided by 3 is 3, and 15 divided by 3 is 5. So my new ordered pair will become 3, 5. And for part 3, we want to find the scale factor this time for the dilation that maps negative 4, 6 onto negative 16, 24. It does not matter which coordinate you look at. You can pick your x's or you can pick your y's. I'm going to choose my x's. Just always make sure that you start with the original. So that -4 is the original. And again, I'm looking for the scale factor. So I want to know when I take that -4 and multiply it by what, will it equal the other coordinate? So that means my equation is going to be -4 times k equals -16. To solve that, we'll just divide both sides by a -4. And when you divide there, -16 divided by a -4 is a +4. So your scale factor there is 4. You would have gotten the same exact answer if you had chosen to use your y coordinates instead. Okay. So here we have a picture and we have two triangles. We have triangle XTR and triangle X prime T prime R prime. And we want to know if that's an enlargement or a reduction. And then what is the scale factor N of the dilation and where is that center of dilation? So let's talk about enlargement or reduction first. Again, primes are the images. So in this case, your black triangle is the original triangle. And that light blue triangle is the image. So since that blue triangle is bigger than the black triangle, that means that this will be an enlargement. Okay, so that takes care of that first question. And then the second question is, what is the scale factor? So again, the scale factor, this is that image over pre-image. Okay, so we need the length of one side of the image over the length of the corresponding side of your pre-image. Again, the image is your primes. So on the top, I need the side of my light blue triangle. And the only side that we know something about is this one here. So that entire side that I'm highlighting in blue right now is not just 8, it's the 8 plus the 4. So 8 plus 4 is 12. And the side that that corresponds to in the smaller triangle is that little side that I just put that blue squiggly around, and that would be 4. So our scale factor is going to be 12 over 4. Okay, and I said to call that N. And again, if you can divide or simplify it, we're going to. And since you can divide 12 by 4, 12 by 4 will be 3. Again, I'll just write scale factor in parentheses here. Okay, and your center of dilation, again, think about your laser from when we were talking about that tiger picture in that first slide. Okay, here would be the start of my laser. I'd shoot it there, it would go to R, R prime. Again, if I start there, that would go T to T prime. So this is going to be your center of dilation. So your center of dilation is, sorry, almost spelled that wrong, is X. Okay. The formatting didn't come in on 5. I tried to clean it up before I started the video here. So it says, what are the coordinates of the vertices of a dilation of 2 of the triangle PZG? And we want to graph that image. Okay, well, if I want to know what the coordinates are, the first thing I'm going to have to do is find out what my original coordinates are so I can dilate them by 2. So all I'm going to do is look at the graph and I'm going to figure out what each of those coordinates are as an ordered pair. The point P is the point 2, -1. Z is the point -2, +1. And the point G is the point 0, -2. So there's the ordered pairs of the triangle that you're looking at right now. And now if I want to dilate that by 2, again, all I'm going to do is take every piece and multiply it by 2. So 2 times 2 is 4. -1 times 2 is -2. For Z, -2 times 2 is a -4, and 1 times 2 is a +2. And then for G, 0 times 2 is 0, and -2 times 2 is -4. So those are the coordinates, but now it also says graph it. So let's take a second and graph that. So P prime is the 0.4, -2, so there's P prime. Z prime is -4, +2, so there's Z prime. And G is the 0.0, -4, so there's G prime. And then we'll just connect our dots. And there is your new triangle. So we want to find the scale factor that maps the pre-image onto the image. And in part A, our center of dilation is at the origin, and in part B, the center of dilation is not at the origin. I'm going to tell you right now that does not matter. They're just trying to confuse you. The only thing that we care about, again, is counting. And again, it is always image over pre-image. Again, image is your primes. So your prime figure has to go on top, and then your other one has to go on the bottom. And remember, when you're on the coordinate plane, you can only count horizontal and vertical lines. That is it. You can't count a line that's on the diagonal. And again, we're just going to make sure that we're consistent with our sides. We're going to do corresponding sides. So in part A, your image is your primes, and again, that is your green rectangle there that I just highlighted. And I'm going to talk about side D prime, C prime. So if I count there, that's 1, 2, 3 units long. So the image on the top will be a 3. Again, I'm going to use that same corresponding side in the blue rectangle. So I need side DC. So that's going to be 1, 2, 3, 4, 5, 6 units long. So again, if you can reduce, reduce. 3 goes into both 3 and 6. So 3 goes into 3 once and into 6 2 times. So your scale factor here is 1/2. Okay, we'll do the same thing for part B. Again, the image has to go on top. The image, again, is your primes. Again, the only side that I can't pick now is this one because that's on the diagonal. You can't count that. I'm going to start with R prime, Q prime. Again, you could count P prime, R prime first. It does not matter. So if I count that, that's going to be 1, 2, 3, 4, 5, 6 units long. And then again, in that bottom triangle, we're going to do that same side, the RQ. That's going to be 1, 2, 3 units long. And again, if you take 6 and divide it by 3, you're going to get an answer of 2. So your scale factor there is 2. Okay, describe the transformation that takes place here. So this time we just want to find the scale factor, and then just say, instead of just saying like the scale factor is 4, we're going to say it's a dilation of 4. So we'll just put it into that notation. So same process that we were just doing. Again, the only side that you can count here is your AC and A prime, C prime. Again, you can only count horizontal and vertical lines. So again, image has to come on top. Primes have to come on top. So I need to count A prime to C prime first. That's going to be 1, 2, 3, 4, 5, 6 units long. And on the bottom, again, I need AC because that's the side that corresponds to. So that's here. So that's going to be 1, 2, 3. And then 6 divided by 3 is 2. So 2 is your scale factor, but the transformation is a dilation of 2. So there's describing your transformation. It's a dilation of 2. Okay. 8. What transformation would result in the perimeter of a triangle being different from the perimeter of its image? Again, the perimeter is the distance around the outside of a figure. So if the perimeter is going to be different, your size of your figure either has to get bigger or smaller for it to change, which means we're looking for what is a dilation here. Okay, 1, that's not a dilation. All you're doing is flipping your X's and your Y's. 2, again, not a dilation. All you're doing is negating your Y coordinate. But 3, we're taking each one of those coordinates and we're multiplying it by 4. That is your dilation. Okay, 4 is a translation. You're just adding something to both X and Y. All that's going to do is slide your figure. So again, choice 3 is your dilation. And last question, number 9. The image of triangle DEF is triangle D prime, E prime, F prime. Under which transformation will the triangles not be congruent? So anytime that they're asking you for a transformation that is not congruent, the only thing that you are looking for is a dilation. So choice number 1 has a reflection. Choice number 2 has a reflection. Choice number 3 has the word dilation. And then choice number 4 has dilation. So it has to be choice 3 or choice 4. For choice 3, again, you don't care where your center of dilation is. The only thing that you care about is a scale factor. A dilation with a scale factor of 1, let's say you started with the 0.68. If you have a scale factor of 1, that just means that you're multiplying X and Y by 1. 6 times 1 is 6, 8 times 1 is 8. That point did not change. That is not going to change the size. But in 4, now you have a dilation of a scale factor of 3/2 centered at the origin. That is absolutely going to change the size of your figure. Again, if you looked at the point above, I did 6, 8. I'm just going to concentrate on the x coordinate there. If you multiplied that by your scale factor of 3/2, again, you can stick that over 1, cross cancel and multiply, it would become 9. So that would be your new x coordinate, and that is going to be your answer there. Okay, please make sure that you go on to do the homework from 8.5, and please make sure that you hand that in on Google Classroom.